So in today's session, we will going to see the SQL injection and business logic issues. Can you go to the next slide, please? Okay, so in terms of the self-introduction, you already know that I'm working in Security HQ as a senior analyst. So you can connect me on LinkedIn and Twitter. For Twitter, you will need some recon skills to find me because it's not that simple handle. Okay, going forward. Yeah. So in today's session, the agenda will be, we are going to see what exactly the SQL injection is. Note that I have created this presentation considering most of the audience will be the students and which are the freshers and new in the cybersecurity field. Then we will going to see what are the SQL injection types, where to find the entry points, what are the methods to find those entry points. How to bypass WAF, impact of the SQL injection when it successfully get exploited by the attacker. Then the business logic issues, how to detect them, examples and what will be the impact. And lastly, we will have the QA session. If you have any queries, you can ask me. Okay, going towards the next slide. Okay, so this is a basic definition of the SQL injection. So this is nothing but the vulnerability which allows attackers to send the malicious code to the user inputs, which are directly interact with the database and getting processed at the database level and provides the output to the user. So can you just click on the next one? Okay, so this is the diagram where you can see the attacker has injected some malicious input in the user field as well as the password. This is again a basic example, but it is in the diagrammatic format. So this malicious input which is provided by the attacker is getting processed and the SQL injection query was generated using that malicious input without any sanitizing or escaping the special characters. Hence, it is directly get executed at the database and providing the unauthorized access to the attacker. So this is a basic flow of the SQL injection. Going to the next one. Okay. So these are the SQL injection types. Again, these are the basics ones that we are going to discuss in detail in today's session. Note that apart from the error-based, union-based and blind SQL injection, there are other types as well, like second order SQL injection, out of band. But you know, since it is a very huge topic of the SQL injection, it is not possible to conduct all the types of SQL injection in a single session. Maybe we can have a separate session or the part 2 session on those SQL injection types. Yeah, so this is just a generic one, which I have used as an example, which is an error-based SQL injection. Next. Okay, so in terms of the error and union-based SQL, again, the definition, I'll just quickly go through of this definition because all of you are aware of the basics. I consider it. If you don't know, just let me know. I'll repeat it. So in terms of the error-based, it provides the, when user inputs any or provides any malicious input into the user fields, database generates an error, and through that error, you will be able to conduct the SQL query, which can provide you the other information which is not intended for you. So this is nothing but the SQL based, and you can see the payload as well, which I have taken as an example, in which we are just simply using a condition where we are selecting the first table name from the table schema. Okay, I'll just use the pointer. Okay, I just have to press. Okay, so here we are selecting the first table name from the information schema, and if it is available, it will get successfully executed, and this condition will get true, and we will get the unauthorized access to the information. If it is not, it will throw an error. And second one is about the union based. Can you just click on the second? Okay, so here I have taken an example of one of the website which is developed in ASP.NET, and this is a typical syntax error you will find if you provide any malicious output for the websites which are developed using the ASP.NET. So through this error you will get to know what exactly the information and where this query was broken after providing the malicious input. And here, as you can see, we have used this payload, and we were successfully able to get the database table name, which is available in the first entry. In terms of the union-based, the name itself suggests we are going to use the union keyword just to extract the information along with the other queries. Again, payload, here you can get the idea where we are creating a malicious query in which first part should be considered as a false, because so that our second union select query get executed at the database, and we will get the table name from the information schema tables, where the condition is the table schema should consider the database which is current database. I hope you are aware of the information schema, right? Okay. Coming towards the blind SQLi, it is nothing but it will doesn't provide you any information, error information, just like we have seen before. You have to check whether your entered query is true or not based on the response, how the application behaves. So just a simple example, if you just click on the next arrow, yeah. So here I have entered the user ID is 1. Note that I have used some of the images from the internet because in the past experience, wherever I found the SQL injection, I'm not able to get those screenshots as example here just because of confidentiality. So I have just taken some basic examples from the internet. So here, as you can see, I have entered the one user ID, and that exists in the database. That's why it shows the user ID exists in the database. And then I just tried the random number, which is 100, which is not exist. That's why it's shown the that user ID is missing. Now, how many user ID exactly present in the database, for which you need to manually search for each of the ID by entering into the input box, and after submitting it, you have to check at which user ID you are getting the error. That means the user IDs which are present is n-1. Okay. So these are the two basic types of blind SQL. One is the Boolean based. The example that we have just seen is about the Boolean based, and second one is the time based one. The example that you can see here, so I have taken just the snapshot of the request that has been captured through the burp suite. So here you can see the multiple parameters are getting passed through the post base body. And this, any one of this can be vulnerable for the Boolean based attack. So for that you need to automate the process, because since the blind SQL injections are very complex one, you need to provide, and you have to spend more time to identify exactly how much and where you are getting the error, and identifying all the background information about the database. So you can take a help of the SQL map like tools to exploit them. So here I have saved that post base query into the one file, and I have provided that to the SQL map tool. And here I have passed some information for which database I would like to ingest the queries on the vulnerable parameter, what will be the proxy should be have in use, what was the method should be used, and what will be the parameter which is more, I think it might be possible for the blind SQLi. For that I have mentioned it. And this is the output that SQL map has provided to me. Okay, this parameter has been vulnerable for the Boolean based, and it automatically provides you the information which is already stored in the database. And the second one is about the time based. Here you include the delays between your malicious queries that you are going to enter into the user inputs. So based on the response, after which time after the time delay that you have introduced in your query, are you getting the response after that certain amount of time, then that application is vulnerable to time-based SQL injection. If it is not, then it's pretty clear that it is not vulnerable for the time-based SQL injection. Okay. So here I have taken the example of the burp suit again. Sorry for the clarity, it is not that clear. But as you can see, it is a multi-part form in which one of the parameter I have supplied the query with the sleep and 8 as a parameter for the sleep for the 8 milliseconds. And you can see in the left-hand side corner, it is, the response has been received after 8.200 milliseconds. So that means the application is vulnerable for the time-based SQL. Next one. Okay, so where to find the entry points? This is pretty simple, and this requires some, again, the recon skills to find the entry points. Note that this is not the only points where you can find. I have just listed down some of the possibilities here. There are other possibilities as well. So first we will discuss about the listed one, and I'll provide you the extra ones that I have in mind. So first is about the login forms. So here, as you can see, again, I have taken an example of this test site. So in terms of the banking, if you find any login page, you have to check whether that username or the password input field is vulnerable for SQL injection or not. Then coming towards the search and query functionalities, sometimes whatever the search function or the query box which is provided by the website process the output at the database level, and sometimes it is taking an input, or there is some HTML code, so you have to process and you have to review the source code for that, whether that search bar is exactly looking the information in the database, or it is just the HTML input which is you're going to select, or the search parameter that you are going to select from the HTML code. So whatever the user input which processes at the database level and providing us the output, that all input fields should be tested for the SQL injection. Then next, about the contact form, feedback forms. Again, these are the points where developers forget to provide and place some sanitization, input sanitization, where you can check for the SQL injection. Apart from that, you can also check for the vendor login form, then user feedback mechanisms. Or there are some others as well, like sales logging or vendor logging. Sometimes they just left from the developers access control list, where they should have to check and sanitize the user input. Then there are some hidden parameters in the request. As you can see, some UID is being passed through the post request. There is some submit button as well. We have seen while testing the demo websites, there are some hidden parameter called as admin or some functionality which set to true, and if we set to false, we don't get that privilege. Again, that is, if that is going to be processed at the database level, that should be again tested for the SQL injection database. In terms of the web application files, I have taken an example of the robot.txt. So again, this gave me the very good success rate because most of the SQL injections point I have found to the robot.txt. And there are other files as well that you can search for on the web application, like config files or any JavaScript or PHP files which are getting hosted and which developer forget to remove those. So that will also lead to provide some sensitive information and the hidden parameters that being processed. Again, don't forget to use the webback URLs. That really provides good results because developers or the company just don't pay attention to their historical or whatever their footprints are. So you can use the webback URLs as well to find the parameters, as well as you can use the name of the files, which can also reveal the function names which are exactly being used in the source code, which can also provide some hints about what can be the parameter passed for that particular file, and that will also lead to the SQL injection. There are some good write-ups as well on the Medium, you can find it. And in terms of the passed through URLs, it's again the example of the gate type of URLs where all the parameters are getting passed through the website URL. So all these finds, apart from these points, you can check for the user agent. Sometimes user agent from the request being processed at the database level, and that also leads to security concern, which leads to the SQL injection. Apart from that, you can also test for the session cookies. If those are not checked for the input validation, again those will give you the SQL injection possibility and information from the database. Again, so all these methods and all these testing, if you do this manually, it will be really time consuming task. So just to work smarter and for time saving purpose, you can use automated tools such as you can take help of the scanners, which are SQL map. Again, while using SQL map, do not directly provide the URL. Sometimes it will not possible for the SQL map to find exact vulnerable parameter. Instead, what I'll suggest, check for the vulnerable parameter as well as try to provide them the database, what exactly the database being used in the backend level. For example, if the website is developed in using the ASP.NET, the possibilities of the database which is used at the backend level is mostly Microsoft SQL Server. If it is a website which is developed in a PHP, that might use the backend database as a MySQL. So if you provide such information to the SQL map type of tools, they will really give you the good results. Again, Akunetics, Bob Suit Scanner, and Haviz, you are all aware of it. Again, in terms of the Akunetics, I'll provide you some suggestions. Whenever you scan the website using the Akunetics, sometimes they provides you the results for the SQL injection with the 95 confidentiality. So most of the users saying, okay, if it is 95%, that is not exploitable. But that is not the case. You have to give a try. You have to exactly find what type of payloads you have to use, which type of encryption you are supposed to use, or encoding to bypass the security mechanisms. So use the automated tools, but in a smart way. Otherwise, it will again waste your time. And second one is the manual that we have already discussed. We have to inject the payload manually into all the user inputs or the parameters that we have identified. But again, that is a time-consuming task. So here I have just taken the example of the SQL map, where I have stored the post-based query, the post request in one file, and I have provided it to the SQL map to identify the vulnerable. Again, if you can see, I have provided the database information as well, which seems to be Oracle in the backend. Okay. And second one is the Bob suite. So yeah, again, this is the another example where you have to find the entry points. Again, do not forget to check about the errors, headers, about the what exactly the database is being used in the backend, because sometimes the database also sets their custom header in the response and provide you the more information about the database. Okay, so next one is bypassing methods. So before going to the bypassing methods, let me tell you the one truth. Most of the organizations think that just by deploying the WAF, they will secure their web application. But no, it's not true. So if your web application is vulnerable for the SQL injection, and if someone finds a way to bypass that WAF, you are still vulnerable for the SQL injection. So even by deploying one or just increasing a count of the WAF will not secure your website. So to bypass the WAF and directly go to the web application, so we can have some methods listed here. Again, these are not limited to, there are lots of methods which you can use. But again, it is depend on which WAF you are trying to bypass, whether it is a security, whether it is a CloudFront by the Amazon. So it is again depend on the WAF, which payload you are supposed to use. Or it might be a Cloudflare. The Cloudflare gave me really success when I use the blue code tamper of the SQL map. So do not forget to try that out if you found the Cloudflare as a WAF. So first method to bypass the WAF is the find the real IP. So in the first case, you are going to directly send out your payload to the application by bypassing the WAF. So how to do that? You have to first find the web application IP address, and you have to paste it into your host file, which plays a role as your local DNS, and it will directly send that your payload to the backend server IP so that it will directly bypass your queries. In terms of the second one, again, when you find any vulnerable parameter, whenever you try to add the some malicious query that being called by the WAF, but some WAF just check for the first few bytes of the post request. So if you add some garbage, or if you just add some random data before your malicious payload, that might give you the success. Again, third one is about the white space replacement bypass. So here you will just replacing the white space in your SQL queries by the random characters. It can be a comment symbols, or it can be a control characters. And last one is about the obfuscation and encoding. So we will going to discuss this in detail. We will see some examples of the obfuscation and encoding in this session. So coming towards the next one, here are some examples that I have taken for the obfuscation and encoding. So first one is about the case sensitivity. So if the WAF is just checking the keyword, particular keyword, you can just use the combination of the lowercase and the uppercase letters to bypass it. Just give a try for that. And in terms of the URL encoding, if your payload are getting locked at the case sensitive, just try it encode by the URL. And as you can see, if your payload is apostrophe or 1 equal to 1, then we are going to obfuscate the other special characters as well as the numeric and the symbols, except the OR condition. So this might give you again the success if case sensitive does not give you the success. Next. In terms of the Unicode encoding, again what we are using is we are just encoding the special characters, numbers and symbols except the OR condition with the Unicode characters. So this will be your final payload if you encode the original payload. Again, if you are not getting a success for this, you have to go for the other one, which is well known for the hexadecimal. This is ultimately giving almost 80% chances of the success that I have seen in my experience so far. And in terms of the comment obfuscation, here we are doing just adding a comment after our malicious payload. Yeah, so impact of the SQL. So if any attacker just successfully exploits the SQLI, it will give you the unauthorized access to the sensitive information which is being stored at the database level. Then it will also cause the data breaches of the sensitive information. For example, if database contains the debit card or credit card information, most probably if it is for the e-commerce website or shopping websites. Again, it will also give you the attacker to ability to manipulate or delete the information from the backend database. It will also cause a system downtime if you are using a burp suite repeater or any tool which is continuously providing the queries with the malicious code which is generating lots of traffic on the web server. It will also cause to the DOS. Again, coming towards the next one, before going to the business logic issues, whenever you find the SQL injection on the MySQL database or the MS SQL database, don't stop there, just give a try for the RC, because sometimes for the MySQL or the MS SQL most probably, the functions like xpcmd, if it is has been enabled on the server, it will give you the directly remote code execution. You can execute the OS level commands on the server. So next one is about the business logic issues. So these are nothing but the vulnerabilities in the application logics. So here you have to first understand what the application is, for what that is being made for. And the reasons why to go with the business logic flaws, because it is really easy to find if you really know the working of the application and the purpose why that application has been developed. And again, these vulnerabilities not easily identified by the scanners like Akinetic, Census, or Nessus, not Census, Nessus. And it also not detected by the WAF and IDS, because in these issues we are not exactly providing any malicious input or any payload which can be detected by the WAF or IDS or the IPS. We are just exploiting the workflow of the application. So we are just misusing the limitations of the user roles or any functionalities which are not intended to. Then you have to check for the user roles and the limitations. What type of user roles has been developed by developer to interact with that application? Is it the super user, admin user, user role? What's their limitations? Because sometimes it is very simple. I came across one application where only 2 users were there who can interact with the application. One is the admin and one is the normal one. And there is a functionality in the application where you can create a group as well as you can add the members or invite your user, and you can delete as well. So I tried inviting the admin. I have accepted the request from the admin, and I tried to delete the account, and unfortunately that admin account completely deleted from the backend. So it is, you can say, the low-hanging fruits. In terms of the working of the each application functionality, again, know the what exactly the working of the each of the functionality which is provided by the developer for that application, and try to exploit their limitations. Just go beyond the box, think out of the box. And again, in terms of the session and authentication handling, in terms of the user session, check how, what is exactly the condition that developer has been put for the user sessions, how many, for how much time the user session is still active after logging out, or are they allowing any concurrent sessions or not. So all this understanding will cover under this session and application and authentication handling. Next. So in terms of the examples, I have taken a very simple ones which you can find, because most probably developers goes for the higher level one and they forgot to patch, or they forgot to set some limitations for the low level checks, such as improper client-side control checks. So here, as you can see, I have added the one product which price at 100, but after manipulating from the burp suit, I can change the product price to 1 and I can buy it at the lower price. So again, this will cause the issue to the business as well. In terms of the 2FA broken logic, can you please go ahead? Okay. So here I have taken an example of the 2FA. Here it is verifying user ABC and there is one MFA code. Again, I'll give you the example. Just try giving a hit whether that user being authenticated without providing the MFA. Or you can use the MFA which is having the active session, means one user is already activated using that MFA and the other user is going to authenticate with the same MFA or not. In terms of the failure to restrict URLs, so again, in terms of the last case, you have to check which application or which application functionalities as well as the files which are hosted on the web server are supposed to be accessible for the authenticated user or unauthenticated user. So if you are able to access the file which is providing the information about credit card details or any backend information for the unauthenticated user, that comes under the failure to restrict the URL access, which is supposed to be accessible only for the authenticated user and not the unauthenticated one. Okay. Next one is about the indirect object reference, which is nothing but the IDOR. You might have heard about this vulnerability before as well. So this is nothing but if you are tampering or if you are changing the user ID. Again, I have just obfuscated some of the parameters. So if I change the user ID here, or any parameter which can provide me the information about the other user, you can see the other sensitive information like the ordered email, the address, the personal information being accessible, which is not supposed to. If I am to get all this information by just changing the parameter ID of the user or their account number, then I can also update it by just changing the request get to post, or maybe I can use the other functionality of the application to update the other users database as well. So apart from that, updating the information, I can delete the information as well, which can create major impact. In terms of the broken access control, can you please click? Yeah. So here, as you can see, for the admin URL, if I send the GET method, which is directly trying to access from the user browser, I'm not able to do that because I don't have the permissions. If I just change the method from GET to post, can you please click? Yeah. So here, as you can see, I have changed the method GET to post, and I have set the password for the admin. And after changing the password, I successfully got the access to the admin profile. So again, this is the low-hanging fruit you can call. In terms of the impact of the business logic issues, again, you will get the unauthorized access to the data. You will, whoever the e-commerce owner or the business owner who has the this business logic errors in their website can cause a financial loss or the reputation loss as well. Because just think of if you have find such a vulnerability on a Flipkart or an Amazon type of major e-commerce web application, that will really lose their reputation as well as a financial loss as well. And again, last one is about the data manipulation and corruption that you can just, we have discussed, we can update the user information or manipulate the database information as well. Next. Yeah, that's it.